So on page 55, we have two Junia questions. The first one says that given n is the midpoint of AB, so right away I start to mark. I have two congruent segments by the definition of a midpoint. It also then gives me that AX is congruent to NY, so I mark those as well. And then NX is congruent to BY. So I already have given to me two segments, so all I need to do is use my definition of a midpoint to state that these two segments are congruent. But then again, I have to look at my proof statement. I am not going to stop when I prove that the triangles are congruent. I have to use CPCTC, corresponding parts of congruent triangles are congruent, to state that these two angles must also be congruent. So we start with our given, use our definition of a midpoint to state our last missing side as congruent, use side, 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 and then because I have congruent triangles, I can say that angle X is congruent to angle Y because they are corresponding parts in a congruent triangle, therefore they are congruent. In the second one, angle A and angle T are right angles. So I know two things. I know I have right triangles and congruent angles. So it could either be an HL situation or I could use one of the other theorems. I'm also given that MA is congruent to TH. This is a leg. And if I look, the hypotenuse of both of these is shared. So I already know by reflexive that the hypotenuse is congruent. I'm given the leg is congruent. So I can prove these right triangles as congruent by hypotenuse leg. And then after the triangles are congruent, I will use CPCTC to state that those angles are congruent. So we write out our given information. I'm going to first state that there are right triangles because right triangles have right angles. This will allow me to use hypotenuse leg later in the proof. I state that MH is congruent to MH by the reflexive property because now I have a congruent leg and a congruent hypotenuse, and I can say that the triangles are congruent. Now I'm not done because my proof statement is asking about the angles. I state that the angles are congruent because they are corresponding parts of congruent triangles, therefore they are congruent. So here are some more practice problems. I'm given that BD is perpendicular to AB, BD is perpendicular to DE. So I have right angles. So I could either be doing HL or some form of the theorems we were doing before. Depends on what information I have. They also give me that BC is congruent to DC. Now, because I have C intersecting lines, I also want to use vertical angles. So I'll have an angle, a side, and an angle. So here's an example of a right triangle where we're not going to use HL simply because it is a right triangle. So I will say that the triangles are congruent by angle, side, angle, and then use CPCTC to state that A is congruent to E. So my first two lines, the first line I rewrite the given statements. The second line I'm stating that I have two right angles based off of the definition of perpendicular lines. The third line I'm stating that those two angles are congruent because right angles are congruent. The next two lines are dealing with the vertical angles, so I'm stating that I have vertical angles and that these angles are therefore congruent. I'm then stating that the triangles are congruent by angle, side, angle, and therefore angle A is congruent to angle E by corresponding parts of congruent triangles are congruent, aka CPCTC. The next one, if we look at the proof statement, I am going to stop when I can prove that the triangles are congruent. I am not going to use CPCTC in this example. So, given that BC is congruent to DC, So we have congruent sides. AC is congruent to CE, congruent sides. So all I need to do is state that these angles are congruent because they are vertical angles. So this proof is rather short. You write the givens, state that you have vertical angles. Those vertical angles are congruent. Therefore, the triangles are congruent by side, angle, side. You should recognize that there are some familiar patterns as we've gone through a lot of these proofs. For instance, when you see triangles set up like this in this sort of bow tie fashion, right, you can usually bank on the fact that you're going to have to use vertical angles. So these two lines of the proof should be pretty familiar to you by now. You should be used to writing, oh, these angles are vertical based off of the definition. Therefore, they are congruent because they are vertical. Number 3, given that YA is congruent to BA, so they have it marked for us, so we have a congruent segments, and that angle B is congruent to angle Y, prove that AZ is congruent to AC. So we're not going to stop with the triangle. We are going to have to use CPCTC to take out those segments and say that they are congruent. Now, just like I was talking about before, you should see the familiar format, the bow tie, and say, oh, vertical angles. So I know 2 of my lines in my proof are going to have to be that angle ZAY and angle CAB are vertical. Because they are vertical, they are congruent based off of the fact that they are vertical. So, as you can see, that is my first 3 lines. Given definition of vertical angles are congruent. Because now I have angle, side, angle. So I can state my triangles are congruent. And then AZ is congruent to AC by CPCTC. Now we're dealing with a set of parallel lines, which is given by these little arrows. I know alternate interior angles are congruent. They also give me a pair of congruent sides, so I have side, angle, and there is a shared side. So using reflexive, I will get that third. So I'm going to be using side, angle, side. And if I look at my proof statement, I do not have to use CPCTC because I am stopping with a triangle. So first, as always, write your given statement. I'm going to state that I have a pair of congruent angles because they are alternate interior angles with which are congruent. Remember, in the front of your packet, there is a glossary and there is a diagram that goes through parallel lines cut by a transversal if you need to review the relationships. After that, we can state that XZ is congruent to XC by the reflexive. And then I have enough information because I have side given to us, angle proven, side reflexive. So I have a pair of congruent triangles. Okay, one more. Given that angle K is congruent to angle M, so right here, congruent angles, L is the midpoint of KM, so I'm going to have a line where I'm going to state that these 2 segments are congruent based off of the definition of a midpoint. And then again, I see the bow tie, vertical angles, so 2 lines, one that they are vertical angles, second they are congruent. So if I do all this, I will have an angle, a side, and an angle. And I am proving the triangles are congruent, so that will be my end. Just by talking things through and marking it down, I have basically written my proof without actually writing it because I've gone through the steps that I'm going to need to list out. So we start with the given. So like I said, because it's a midpoint, the first thing I want to do is I want to make sure that I say these 2 are congruent based off of the definition of a midpoint. Cool. Then, like I said, we have the bow tie, we have vertical angles. They are vertical angles, therefore they are congruent because vertical angles are congruent. Check. We were given K and M, so I already have A, I proved S, and I proved A. So therefore my triangles are congruent by angle, side, angle. last one for this lesson. Given that angles B and D are right angles, so I have right triangles, again, you have to think, am I going to use hypotenuse leg just because it's a right triangle? No, you have to take the information that they give to you and label it on your diagram. So, because they're right angles, I know they're congruent. That could be another way that I'm going to go with this. It also states that AE bisects BD. Because of this, we're going to have congruent segments. Now, they didn't tell us anything about the hypotenuse. They're actually asking us to prove that these are congruent. So I am going to say we're not going to use HL. And what we can use is our favorite little bow tie to say that we have vertical angles. And because they're vertical, they are congruent. So I have to state that these angles are congruent because they are right. These sides are congruent based off the definition of a bisector. And these angles are vertical and therefore congruent. Again, I've just laid out my proof. I will then be able to use ASA, angle side angle, to prove the triangles are congruent, and then CPCTC to take that segment out and say that the corresponding parts of congruent triangles are congruent. So, seeing that written out, angle B and angle D are right angles, angle AE bisects BD, given information. Because we have right angles that are congruent, I have a pair of congruent angles. Definition of bisector gives me my segments. Then we have our 2 line for vertical angles to give us our third component, our last angle, to say that the triangles are congruent. Therefore, AC is congruent to EC by CPCTC.